Hey guys, Jake here, coming at you with another math problem today. I wanted to show you some center of mass example problems. So today I'm going to be showing you this one right here. We're going to sketch the region bounded by the curves and then find the exact coordinates of the centroid of that region. And the curves that we have are y equals 4 minus x squared and y equals 0. So before we jump into this, I do want to just point out one thing, and that is kind of the difference between a centroid versus center of mass. And the reason I want to bring that up is because obviously you can see this problem is asking us to find the coordinates of the centroid, but I said I was going to show you center of mass example problems. Well, they're pretty much the same thing in most contexts. This context specifically, they're going to be the same. Really the only difference when you're looking at a centroid versus a center of mass is a center of mass is referring to basically the center point of some actual physical object that actually has a mass. So like the context that you'd usually see for that is saying that you have like a thin plate basically, which is described by some functions or some region, and you want to find the center of mass of that plate. Where centroid usually comes into play is where you're just described some region that exists bound between two curves on an xy plane. So this case here, we're basically just given these functions, and we're looking at the region that is trapped between those functions. And since we're looking at some region, centroid would be the proper terminology there. But if you're ever given some uniform density object, like a thin plate, for example, if you know it's uniform density, the centroid and the center of mass are actually going to be the same thing. So you would get the same point whether you were thinking of it in either context. But in this case, centroid would be the proper term to use. But again, they're going to use the same formulas basically to figure those out. So that brings me to the center of mass equation integrals, which are two equations that are on my Calculus 2 study guide. If you haven't checked that out, there's a link down below where you can check that out. You can go download that right away. It's only a few bucks. It's pretty affordable. And I highly recommend you grab yourself a copy of that. It's available right away, so you can go start using that today. The link is down below. But let's go ahead and jump into this problem. So like it says, the first thing we want to do is sketch the region bounded by these curves. So let's go ahead and start with that. So we'll just start with an xy axis here. So this function here, y equals 0, is just going to be, this line right here, the x-axis. And then this 4 minus x squared, y equals 4 minus x squared, is actually going to be a downward facing parabola with its vertex at the point 0, 4. So the vertex will be right there, and then we'll have a parabola basically going like this. It would intersect with this line at x equals -2 and x equals +2. So you can see this region here that we are trying to find the centroid of. So once you've sketched your region and kind of given yourself a visualization of what we're trying to do here, probably the best place to go from there is to just go straight into the center of mass equation integrals. So the center of mass equation, there's actually going to be two of them. There's a separate, basically there's one for the x coordinate of the centroid or the center of mass, and then there's one for the y coordinate of the center of mass. So I'll just go ahead and write those equations down here real quick. So these are going to be the two formulas for the x coordinate of the centroid and then the y coordinate of our centroid. So before I show you how to use these, I do just want to kind of point out the different pieces here. So first of all, we have this capital A here in both of these equations. This capital A is basically just the area of the region whose centroid or center of mass we're trying to find. So basically we would first need to figure out the area between these two curves here. And that's what A would be. I'm not going to show you how to do that in this video. I have made another video where I show you how to find the area between two curves. If you want to check that out, you can click up at the top of your screen. I'll put a little info card up there that'll take you over to that video. Then we have the bounds of our integrals, the A and B. It's going to be the same for both of these. Those bounds of the integral are basically just going to be the x values that are the left and right edge of our area or our region. So in this case, little a, the lowercase a, is going to be -2, b is going to be +2, and that'll be true for both of those. And then we have this f of x in here, So that f of x is basically just the function that creates this region. So in this case, since we're going, just down to y equals 0, these formulas pretty much are built off the fact that you're going down to y equals 0. And based on that, this f of x is just going to be this top function, the 4 minus x squared. So you can kind of use those pieces, and I'll show you how to do that. However, before we do that, I do want to point out one thing. This is an interesting example because you can see this area that we have, this region, is actually symmetrical in the x direction, right? We can kind of sketch this line of symmetry right here, right down the middle of this region, and this region is symmetrical to the right and to the left of this line. So whenever you have symmetry in your region, that actually saves you some work, because since we have symmetry in the x direction, that actually tells us that the x-coordinate of our centroid must be on that line of symmetry. So as a result, we actually already know right off the bat, without actually doing any calculations, that our x bar is going to be 0 because this line of symmetry is at x equals 0. So in this case, we already know that x bar is 0. So all we really need to do is use this formula to calculate y bar. So to do that, we would just take y bar equals 1 over a, and again, a is the area of this region. And if you use that method mentioned in the other video that I brought up before, you would figure out that the area of this region is 32 over 3. So we're going to get 1 over 32 over 3, and then we're going to get the integral from a to b, and like I said, that's the left edge and the right edge of this area, so negative 2 to 2 of 1/2 times our function f of x, which is this 4 minus x squared, our top function that creates this region. So 4 minus x squared is going to be f of x. And then we're going to have that whole function squared, and then a dx. So I do want to point out, it is important, remember when you're doing these equations or using this equation, that you put your f of x all in brackets or parentheses, because we want to make sure to square this whole function. So from here we can kind of simplify things a bit. So whenever you have a fraction in a denominator like this, basically what that means is 1 over 32 thirds is the same as 3 over 32. We can flip that denominator and kind of bring it all into just one fraction. Then we'll have the integral from negative 2 to positive 2. This 1/2 we can actually bring out of our integral because it's just a constant being multiplied by this whole thing over here. So if we pull that out, what we would actually do is multiply this by 1/2. So 3 over 32 times 1/2 will be out in front. Then we'll have 4 minus x squared all squared, which you want to be careful with this. You want to make sure that you treat this as 4 minus x squared times 4 minus x squared, which means we're going to have to FOIL this out. So we'll get 4 times 4 is 16. 4 times negative x squared is negative 4x squared. Negative x squared times 4 is negative 4x squared again. And then negative x squared times negative x squared is positive x to the 4th. Then if we simplify this, we'll just get 16 minus 8x squared plus x to the 4th. So this is the same as this piece right here. So we're going to get the integral from negative 2 to 2 of this whole thing. 16 minus 8x squared plus x to the 4th. And I'm not going to go through all the steps of integrating this. You could definitely do that yourself, but I definitely would recommend doing it. But doing this can just be done using the power rule, right? So we would just raise our power by 1, divide by the new power, and then evaluate this, that integral that you would get from negative 2 to 2 by plugging in 2, plugging in negative 2, taking the difference between them. But when you evaluate this integral, you would get 3 over 32 times 1/2 times 512 over 15. Because 512 over 15 would be the result of this integral. And then if we simplify this, we would just get 8 over 5. So that tells us that the y-coordinate of our centroid of this region is 8/5. And we already figured out that the x-coordinate of our centroid was 0. So that tells us that the centroid of this region between these two functions is going to be x equals 0, y equals 8/5. So it would be at the coordinate, or the point, 0, 8/5. So like I said, this center of mass equation integral is one of the formulas in my Calculus 2 study guide. There's a link down below if you want to check that out. If you found this video helpful, please give it a like. Be sure to subscribe to my channel. I'm sure we'll be able to help get you really good grades in your calculus class. Thanks, and see you next time.